Good day, everyone. Today we are going to learn how to check the quality of steel bars at construction sites. We have a total of 7 tests that we are going to study. And my name is Arslan, and welcome to my YouTube channel, The Third Dimension. So, how do you check the quality of steel bars at construction site? Steel bars they're one of the most expensive materials that we have on construction sites. And they're even the biggest contributors when it comes to the strength of our structures, right? So they contribute the most when it comes to the durability and strength and stability of our structures. So we have to make sure that the steel bars that we have on site, in fact, let's call them rebars instead of steel bars. So we have to make sure that the rebar we have on site is adequate, it's correctly ordered, and then once it's ordered, it's properly secured and stored within our sites. So usually as a site engineer, we have 7 different tests that we can do on rebars to make sure that they fulfill whatever requirements we have in our standards, all right, in our construction standards. So let's get started with the tests. At number 1, we have checking the manufacturer test certificate. Every batch of rebars that we order, it comes with a manufacturing certificate. Within that certificate, it has its manufacturing date, its expiry date, its temperature limits, and its chemical compositions, and all other necessary properties it has. So make sure as a site engineer, you check the manufacturer's certificate, which comes with the batch of the rebars that we have ordered. So that's the first test. And the second test is checking the grade of the steel. Steel bars or rebars, they have different grades. For example, grade 40 and grade 60. So make sure as a site engineer, you check the grade of the steel, and so that you can make sure that the rebars are strong enough to sustain the loads of our structure, right? So the second test is checking the grade of the steel. Let's move on. At number 3, we have check for rust and unwanted debris on it. So this is the third test, and when you order a batch, there shouldn't be any rust on its surface. And although minimum amounts of rust are acceptable, but there shouldn't be any noticeable amount of rust within our rebars. And for example, if there is some sort of rust happening on its surface, then methods like sand blasting can be used to remove it. But overall, there shouldn't be any rust or unwanted debris on it. So next we have is check for physical damage or deformations. We have to make sure that during the transportation and storage and manufacturing, there isn't any undesirable amount of, there isn't any physical damage or deformations, right? There's not any bends within our rebars. And as you can see, the first point is any undesirable amount of foreign material is not acceptable, which is again part of this test. And similarly, also checking for critical deformations or splits, which is what I said in the start, during the transportations or storage or manufacturing or loading or unloading of our rebars. Mostly the deformations happen at that moment. And as you can see, even the third point again says that there shouldn't be any bends or crushing which might have occurred during transportation. So this is the overall test, checking for physical damage or deformations or bends or crushing damage. There shouldn't be, the rebar should be straight, and they should be durable and undamaged when they arrive on site. Similarly, next we have is checking the mass per meter one of our rebars, and this is the most important and the most widely used tests of rebars. In this test, we calculate 2 values and then we compare them. One is the practical mass per meter one on site, and the other one is the theoretical mass per meter one, which is calculated using the formula, which is written on the bottom right here, d squared divided by 162.2. So the method is that we cut a 1 meter length rod from different reinforcement bundles or different batches, and then we weight that bar, and then we record its mass per meter one, all right? So we record the mass which every 1 meter length of a rod has, And we do that to about 5 or 6 samples. We calculate the overall average. So that's the practical mass that we have calculated on site physically. And then theoretically, we use the formula d squared divided by 162.2, which again gives us the mass per meter run. So both of the practical and the theoretical values should be the same, right? And if you talk about uncertainties, it can be about plus minus 2 to 5%, okay? 2 to 5%, but it shouldn't be more than that. So calculate the mass per meter run and compare the values. Next is the bend test, which is at number 6. In this test, we bend the rebars to a degree of 180, or we bend the rebars by 180 degrees as per IS 1599 in a mandrel. And then once the bars are bent, we check for cracks or rupture on the tension side of the bent bar, right? So if there are no such issues or no uh, physical signs of damage or cracks or rupture, then the rebar has passed the bent test. So even the pictures below that we have, they're representing whatever I've said above. We bend the rebars to 180 degrees by by using mandrels, and so this side right here is going to be the compression side, while its opposite side is going to be the tension side. So we have to make sure that there are no cracks or rupture on its tension side once the bar or the rebar is bent to 180 degrees. So that's the 6th test on site. And then lastly we have is the rebend test. This test is again similar to the bend test which we previously studied. In this test, we rebend the bars at an angle of 135 degrees. And once it's bent, we keep the sample in boiling water for 30 minutes. Then we remove it, we cool it down, and once it's cooled, then we again bend it to 157.5 degrees, right? So it can be 160, let's call it 160. So we bend it to 135, we keep it in boiling water for 30 minutes, and then we remove it, and then we again, once it's cooled, we again bend it to 160 degrees. So after all this process, if no bends or cracking is formed, it has passed the test. Okay, so this is the 7th test of rebars, and it's something similar to the previous one. So finally, this is the last slide. There are a total of 7 tests that we studied. Or this is, you could say the final summary. So the first one was checking the manufacturing certificate, then was checking the grade of steel, then it's checking for rust or unwanted debris, inspect for any physical damages, and check the mass per meter run. Then is perform the bend test, and then the rebend test. So these are a total of 7 tests that we have to on construction sites for steel rebars. Okay, so thank you for watching this video, and I hope you learned something, and stay tuned with us for more interesting and short and simple videos regarding construction sites or regarding civil engineering or site engineering. So thank you.